Axel from Strategy. Welcome.
Yeah, thank you for the introduction and also a warm welcome from me to the audience here in Frankfurt. It's very lovely that you are all here. And today or tonight, I'd like to talk about competitive advantages with or through knowledge graphs and graph technology. And my name is Axel. I'm the co-founder and managing director of Structure GmbH, a German company here in Frankfurt. Today, I'd like to talk about a little bit about our company and what we do. Give a short introduction on graph technology, knowledge graphs. We'll try to explain what knowledge graphs are, and give some example use cases and talk about the competitive advantages organizations and companies can gain from using knowledge graphs and graph technology. So we are a small GmbH, small company based out of Frankfurt. This is the structure team. We're 11 people, and some of them are sitting and standing behind of you all. So if you have any questions about what we do in our software, please don't hesitate to just talk to them, and hopefully they will answer and give you some explanations later on, and or maybe show you our product. So we have two mission statements. One is all about people. So we want to bring graph technology to organizations and companies. So helping organizations in their digital transformation through graph technology. And the second one is we're also a software vendor. We want to create tools you enjoy working with. So we make a software that makes your task of software development more efficient, predictable, and hassle-free. And we try to, or hopefully our clients say we do, create user-friendly software tools. History of Structure, we started in 2010 with an open source project, also called Structure, and founded a small company. Started with 2 people, my brother Christian and I. We named it to Structure GmbH in 2015. Headquarters are in Frankfurt, and we are currently 11 people at 2 locations. Our business is mainly creating the structure graph application platform. This is what we call our software. We do individual software development projects and graph technology consulting in general. So some of our customers and clients. So this was the advertising. Now let's get to the real stuff. So talking about graph technology. What is graph technology? First of all, there are graphs, of course. And graphs are, in our opinion, the best abstraction you can have for almost anything of the real world. So the world is a graph, and in this graph area of the graph world, we always say the world is a graph, because you can not only abstract physical objects, you can also abstract concepts and relations as graphs, or interactions between people, between physical objects, relations of all kind. And who of you knows about the 7 bridges of Königsberg? Yeah, very good. So there was a Swiss mathematician called Leonhard Euler, and he tried to solve the problem of the 7 bridges of Königsberg. So Königsberg at that time had 4 districts. They were separated by the Prege River, and there were 7 bridges. And the question was, can one travel all districts by using each bridge exactly only one time? And so he abstracted the problem as a graph, and he called it or he said, okay, let's have vertices or nodes for each district and relationships for all the bridges or edges. And his conclusion was, or he was kind of the founder or inventor of the graph theory, and his solution was he found that it's not possible to cross these bridges only one time. So about 250 years later, we have lots of models that are all graphs. In computer science, we tend to think in graphs. So, for example, in the 1970s, entity relationship model is the basis for modern SQL databases. Or unified modeling language to model interactions or class hierarchies, object hierarchies, was invented in the 1990s. Or the semantic web with RDF, Resource Description Framework, was founded or first described in the 2000s. And so graphs are a very common concept in computer science. But why does the world think in graph technology only since like 2013, 14? What's the reason for this? This chart shows the relative popularity of different database models. So the red line is relational databases, red because of Oracle, I think, and some other database models, but one curve really stands out. These are the graph databases. So graph databases are really popular since almost now the 5th year. And so what's the reason for that? Why is it that graph databases constantly grow faster than other database models? So my theory is there are two reasons. One is simplification, and the other one is technology. Simplification because of a very, very simple model. It's called the property graph model. It consists only of 3 elements, or 3 components. We have nodes, circles. We have edges or relationships, typically drawn as an arrow because they have a direct connection, and attributes or properties. And the other reason is technology. So the native graph database was invented in, I don't know exactly when, but 2007, around that time. And this was really a game changer for databases because a native graph database has 2 very important characteristics. First of all, the joins you typically do in a database are done at insert time. That means that all your connections in your data are already present on disk when you have inserted the data. So when you query the data, if you read data from, which happens much more often than writing the data, you don't have to do this CPU heavy and computing heavy join operations or MapReduce operations. So there's a technical reason why graph databases are really beneficial. And the other reason is that the data is stored on disk as pointers. So traversing the graph is just chasing pointer IDs on disk, which is very, very fast and even faster on SSDs. So this native graph database storage mode is also highly optimized for SSDs, solid state disks. And the good thing is that with this very simple and generic database model, you can abstract or you can map all the other models as well. So you can use the graph database for almost any other graph use case. And that's a very big advantage. Okay, talking about technology. Of course, a graph database or graph database systems have to have an implementation. And the ideal implementation, of course, is graph technology. So all the systems that use graph databases and graph applications, because it's simple and intuitive. You can just go to a whiteboard, draw some circles and lines, and you have a graph. And you can persist that graph in your graph database or you can see it in your graph application exactly how it works. So that means that you have fewer technical layers. It's a big advantage when developing software. You have fast queries without join operations. And last but not least, graph databases are schema-less. That means that you don't have a fixed, very rigid data model. You can change data model at any time in your graph database. We are making heavy use of this freedom. That's very, very important. So, and what do we see in our graph database or graph technology space? The systems become more and more intelligent, or tend to be tend towards more and more intelligent systems. Started all with content management systems. Most of the graph databases, also our software, started as a content management system. But then, of course, recommendation engines came along, social networks, knowledge graphs, is what I will talk about today, decision trees, master data management, configuration management, risk management. And it turns out that graphs are a very important component of intelligent systems like machine learning systems and almost towards artificial intelligence. So the industry of graph database or graphs, technology industry believes that they will be part of really artificial intelligence systems because they provide context, very important thing in this use case. And also the technology has evolved a lot from a simple graph database with an API and programming interface, the query language and some tools to load data, some additional tools like visualization, analytics, drivers, and so on. All this has evolved into an integrated application integration platforms, and one of these platforms is our platform. So we call it Structure, and we integrate all these tools and really integrate it in a user-friendly system. This is the graph technology landscape by our friends from GraphAware. So it's a very mature industry already with lots of tools and companies doing services. So in our software, we can define applications as a graph, a very flexible semantic metadata model, which is a knowledge graph. We'll come to that later. I will just step to that very quickly. You can read it later on, but these are some facts about our software which make them the ideal software for graph applications, in our opinion. So I'm going to try to build tools you enjoy working with. Knowledge graphs. So what should we do with this kind of software? Knowledge graphs are a real big trend. So these are the hype cycle charts of Gartner. So it's a typical innovation curve, like innovation. So I will read it because it's kind of funny. So here the first section is innovation trigger, then peak of inflated expectations, through the true of disillusionment, slope of enlightenment, and plateau of productivity. So that means that here you have all the emerging technologies, and some of them make it to the top, some not. So last year, knowledge graphs were about here, and this year they have come up to here. So most analysts think that graph technology is on the rise, and also will stay. Okay, what are knowledge graphs? First, you have just data, isolated data points, data elements, and if you give them meaning or add semantics, then you have information. If you connect these isolated data elements, then you get knowledge, and if you are able to let the system answer questions about elements, and you get insight from your graph, from your information. And if you are able to follow paths and make predictions out of your graph data, then you get wisdom. This is what everyone tries to teach software systems, to be intelligent so that they can kind of make decisions or act as humans. So therefore, of course, we need wisdom. And this is very nice images from nice people at Gaping Void. And there are many other funny images like this, like with creativity that's completely confused and so on. But they added one very important image, impact. So to make a positive impact on your organization, your company, you have to do something. And mapped on technology, we have traditional databases. They come up about this way. Graph databases are very good in connecting information in a graph, or as a graph. And from here you have to build applications to map it to your use case. And this is very important because only here you can make a real impact. If you build a knowledge graph, a system which matches your use case, solves your problems. And all this is best described as graph technology. Some examples. What did we do when we built knowledge graph applications for our clients and customers? One is in the area of compliance management and anti-money laundering. There's a huge problem. You can read the numbers, worldwide and widespread. And what you want to do is you want to know your customer, or you want to know your business partner. So you build a network of, for example, companies, people, and there are lots of documents in it. They describe these relationships. And you can imagine that this graph grows very, very, very big. And to efficiently query that graph, you need graph technology, you need a graph database, and graph applications that can cope with this kind of data. And what we did is build a compliance management tool. It's a very scalable graph system for our client Cabal's compliance management systems in Cologne. And it supports the compliance managers. They can do KYC processes and due diligence processes. There's a highly automated reporting that saves them tons of hours and even days per month. There's a semi-automated tool to report suspicious activities. Their clients are in the sports betting area, so you can imagine that there are some suspicious transactions or activities suspicious to money laundering. And very, very important, for example, in semi-automated reporting to the FIU, which is the authority which takes care of these suspicious activities. And last but not least, it's ongoing development, self-service web applications for their clients. So they can, speaking of competitive advantages, they can serve thousands of clients with a team of just 40 people. So it's a really, really scalable system. Another use case is a system we built for the toy company Schleich. Some of you might know this, small plastic figurines. They have the problem that if people call at the help desk and ask what's in it, what's in your product, and what's allowed. So what are the legal limits? Because of course these figurines are used by small children, and of course you want to take care of them. So there are very, very long paths from the product or the manufacturing process steps, the built-in materials, the substances these materials are built of or made of, the batches, they are packaged together. Some of these batches are lab tested. These measurements have some values and have to document if they comply to legal limits. The legal limits are written down in laws, and then you have, of course, many, many laws that have to map or are applied in the local context because they are international manufacturer. So that means if someone calls, you have to give quick answers and short answers, so they really can do that in real time. And we built a semantic product data management system for them. So these two use cases in our opinion, prove that this conclusion is true. We should use graph technology to build knowledge graph applications to make a positive impact on your organization. So that was it. Any questions?
Yeah, I have a question. So you showed one example regarding the compliance and the anti-money laundering. So does this? You showed one example with the compliance and anti-money laundering scenario. Just wanted to know if your tool also identifies a relationship between different entities automatically. Like, okay, I inject my data, I have multiple data sources, and now the question is to do the investigations. So, in terms of finding the relationship, does it automatically does that? Like, for example, Neo4j and other tools do that?
Yeah, it's all based on Neo4j, so it's exactly the same technology, yes, and it does that, yeah. So you can derive relationships that were not directly visible in the graph. So you can use it for fraud detection, for example, to detect fraud rings, like very long transactions that where the money eventually comes back to the same person or a legal entity. Yes, this is just done by very simple graph queries. And these graph queries, even if you have hundreds or millions of nodes and relationships in a database, are all milliseconds. So it's almost no effort to get these queries answered by a graph database.
So it's all based out of Neo4j?
Exactly, yeah. At the moment we're using only Neo4j as a graph database because they are number one in the industry. Any more questions? I'm available for questions all night, so.
Just one quick one. So, a great presentation, first of all. Axel, great presentation. My name is Vivek, I'm from PCS, Power Consulting. One quick question was about customer data platforms. I know that it's not very large, but it looks like what you do here can be applied to the whole marketing angle of building customer data platforms as well, or do you think differently?
Yes, I think so. So there's no natural limitation, or there are no limitations in the range of use cases where graph technology can be applied to. There are some use cases which are not very where graph technology is not feasible. Like, for example, if you have very uniform, non-connected data, like a phone book or something, or adding transactions to a long list. Better not do it in a graph database. But everything which is about connected data, no matter what use case or business area, can be very efficiently be handled in a graph technology solution.
It would be hard because it's all disparate data.
Okay, so maybe any other questions, please just come to me after the talk or after the other presentations. Thank you very much. This is where you can find us or follow us, and yeah, thanks for listening.